video is about the test of difference between two means. So let's start with a definition of the type of problem we're talking about. We are going to compare the means of two independent populations, and we're going to use a hypothesis test to do it. Now, the parameter we're testing is the difference between the population means, mu1 minus mu2. We're interested in whether there is no difference or whether there is a positive difference. No difference meaning mu1 equals mu2, they're the same. A positive difference where the mu1 is greater than mu2, or a negative difference where mu1 is less than mu2. So since the difference involves the relationship between two population means, there are, as we have in the other hypothesis tests we've done, there are 6 possible relationships in the claim. Less than, greater than, not equal, less than or equal, greater than or equal, and equal. And we have a table here where we have the 6 possible claims, and I've written the entire claim out here. The first one would be the difference is less than 0. But if we were to add mu2 to both sides, the left side now becomes just mu1, and the right side becomes mu2. So we can write this as mu1 is less than mu2. And in the 5 other relationships, in a similar manner, mu1 greater than mu2, mu1 not equal to mu2, mu1 less than or equal to mu2, mu1 greater than or equal to mu2, or mu1 equals mu2. And since we're using the same relationships we've used for claims in all of our other hypothesis testing, H0 and H1, the null and alternate hypotheses, are going to basically be the same relative relationships. And H0, the null hypothesis, which will basically be the assumption as well, is always that the two are equal. In other words, the difference is 0, okay? So mu1 equals mu2 is always the null hypothesis here. H1, again, just like all the other hypothesis tests, if the claim did not include equality, it was less than, greater than, or not equal to, then mu1, or H1, the null hypothesis, is going to be the same as the claim, okay? And if the claim does include equality, less than or equal, greater than or equal, and equal, then the relationship in the alternate hypothesis is going to be the complement of the relationship in the claim, greater than, less than, or not equal. So everything in terms of relationships is the same as what we've been doing. And again, also, if the claim did not include equality, since H1, the alternate, is the same as the claim, it is basically the claim. And since H0 is always equal, the null is always equal, then when the alternate includes equality, we're saying that the null hypothesis is the claim. And the alternate hypothesis, again, if it's left tail, less than, it's left tail. If it's greater than, it's right tail. If it's not equal, it's two tail. So everything in terms of relationships is going to be the same in this kind of hypothesis test. We can collect a sample from both populations, and the sample sizes do not have to be the same. And we're also assuming that we don't know the standard deviations, and we're going to say that we'll assume that the two standard deviations for the population standard deviations are not going to be the same, and are not going to be equal in every case. The test statistic we're going to use is another t-test statistic. It is a t-test statistic, has its own degrees of freedom, etc. but it has the form where the sample statistic is the difference between the sample means, x1 bar minus x2 bar. And then the parameter is mu1 minus mu2. We're subtracting it. And then we've got the square root of s1 squared over n1 plus s2 squared over n2. And that basically would be the standard deviation of the difference between two means. And since we're assuming that in H0, the null hypothesis, that's going to be our assumption, that mu1 equals mu2, which means the difference is 0, that mu1 minus mu2 in the test statistic formula can virtually disappear. So we're left with a numerator of x1 bar minus x2 bar, and then the square root in the denominator. Now, the degrees of freedom that we would use if we were doing this by hand is we would pick the smaller of n1 and n2 and subtract 1 from it. Okay, so that would be the degrees of freedom. It's a smaller degrees of freedom, and basically it makes it harder for us to reject a null hypothesis. It's more conservative. But we are going to, for these tests of difference between means, we are going to use a calculator test to do our step 2 and step 3. Because remember, all the calculator tests give us a test statistic value and they give us a p-value. So basically, we're using the p-value approach for all of our tests of difference between means. So we can use the calculator test, and the calculator test for difference between means is called the 2-SAMP-T test. You go to stat, right arrow to test, just like you do for for the other hypothesis test on the calculator, and it's number 4. So we're always going to use number 4 for these tests. It calculates the actual degrees of freedom using a complicated formula, and if we want to see that, we would hit calculate when we get down to the bottom of the input screen. And the results would show us the test statistic, a t, test statistic, and the p-value. And it would also show us the degrees of freedom if we're interested in that. Okay, so let's go ahead and start looking at problems here. Let's look at the first one. Lake Purity and Lake Pristine are polluted with lead. A chemical company claims that the lead pollution level parts per million of Lake Purity is greater than that in Lake Pristine. So we've got two populations. We've got the pollution levels in Lake Purity and the Lake Pristine pollution levels. And they're taking samples of water from both, a set of samples from both. So they've got two samples, a sample from the first one and a sample from the second one. And we're given the data from both of those. We're given the Lake Purity statistics, which is x1 bar, s1 and n1, and the Lake Pristine, which is x2 bar, s2 and n2. So mu1 basically is the mean from Lake Purity, and mu2 is the mean from Lake Pristine, which means that the claim is that the mu1, or I'm sorry, Lake Purity mean, mu1, is greater than that in the Lake Pristine, than the Lake Pristine mean, mu2. So we got mu1 is greater than mu2. It's a right-tailed test. Alpha, we're told, is 0.05. And the null hypothesis, remember, is always equal. Mu1 equals mu2. And the alternate, since the claim did not include equality, the alternate is going to be the same as the claim. And now for step 2, this test statistic, and for step 3, the p-value approach, we're going to take those, get those from the 2-SAMP-T test. So let's take this information that we've got right here and go to the 2-SAMP-T test. Let's see if I can remember these correctly, but let's go to the calculator. Oops, stop share, and let's share the calculator. Okay, I think I didn't do that right. Share the calculator. There we go. All right, so let me clear this out. And let's go to the tests, which are in stat, right arrow to tests. And we want the 2SAMP t-test, which is number 4. So I'm just going to hit number 4. And now we got to put in all the statistics. The statistics from the first sample and the statistics from the second sample. Okay, so let me go, we got 95, 14, and 23. And enter. Oops, I'm going to use the down arrow. 95, 14, and 23. Oops. And then the second sample, 88, 15, and 18. And then the relationship between the two means was greater than. So I'm going to go down and over to greater than and hit enter to make sure that's highlighted. And we'll always leave pooled as no. Do not change that. Or if it does say yes, change it to no, because that implies that we're assuming that the two means are not the same. And then we're going to, and for this problem, I'm going to go ahead and I'm going to go to draw, and it will give us a test statistic and the p-value. So there's our p-value sketch. The test statistic is 1.527 to 3 decimal places, and 0.0679 is the p-value. Okay, so let's go back to our document. And so we've got the inputs and the p-value sketch with the test statistic and the p-value. And then all we have to do from that is complete the test with the decision and statement of conclusion. We can always compare the p-value to alpha, and 0.0679 is bigger than alpha, therefore we'll fail to reject 8.0. And the claim did not include equality, and we did not reject 8.0. The flow chart tells us that there's not sufficient sample evidence to support the claim that the first mean is greater than the second mean. Let's go to the second problem. Test at the alpha equals 0.05 level, the claim that the mean length of a murder trial in days is less than that for an embezzlement trial. Again, we've got claim information. We got alpha equals 0.05. Claim is that the first mean for murder trials is less than the second mean for embezzlement trials. So the murder trials is from the first sample. Embezzlement trial information is from the second sample. The claim is the mu1 is less than mu2. Again, the null is that they're the same. And since this claim did not include equality, the alternate is the same as the claim. And we'll again use the calculator 2SAMP t-test. and put the information in 35, 37.5, and 30, and we got to make sure we get the mean and standard deviation and the sample size into the correct line of the input. So 37.5, 5.5, and 37.5, 5.5, and 35. So that's what we need here. Oops, let me stop sharing and share the calculator. Let's clear this out. Let's do stat, right arrow to calc, number 4. And again, we want 37.5, 5.5, and 35. I believe that was 37.5. 5.5 and 15. No, 35, sorry. And the second one was 41.282. And 35 as well. But, and this one was less than, so we need to make sure that we've got less than highlighted. Put the cursor over that and hit enter. And again, pooled stays the same. And we'll go over to draw and enter. And we see a very small area underneath the curve to the left of the test statistic, which is negative 2.2169. The p-value is small. That's that area right there. Probability of observing a value of the test statistic farther from the mean than what we actually saw, which was negative 2.217. So 0.152 is a pretty small p-value. So stop sharing, share, select. And let's see what the result is then, the decision. Since 0.0152 is less than 0.05, we're going to reject 8.0. And basically, we're supporting the claim then. Claim didn't include the condition of equality. We rejected 8.0. There's sufficient sample evidence to support the claim that mu1 is less than mu2. Let's go to the next problem. The mean annual tuition of a random sample of 16 state university students in 1990 was 18,900 with a standard deviation of 1,100. The mean annual tuition of a random sample of 25 state university students in 2000 was 19,500 with a standard deviation of 500. At the 0.05 level, test the claim that the mean tuition remained constant from 1990 to 2000. In other words, it was the same in 1990 as it was in 2000. So that means the two means were equal. So here is the data. 1990 would be the first sample, or the first population. 2000 would be the second population. So we got 18,900, 1,100, and 16. And so let's go back to the calculator. Clear this out. 2SAMP t-test, stat, right arrow to tests, and number 4. Let's go down to 18,900, 1,100, and I believe we're looking again at 16 and 25 for the other one. So 16. Then this was 91,500, or 19,500, sorry. 19,500. And the standard deviation of the second sample was 500. And 25 was the sample size. Now we're looking at equality. So we highlight that. Cannot believe I did that. All right, stat, right arrow to calc, 4. Numbers are still there. Highlight, enter, leave pooled at no, go over to draw and hit enter. And we get a p-value sketch that shows the area underneath the curve for values that are farther away from the mean than the negative 2.050. This actually is 0.04 something, negative 2.050. And once we find that area, we would multiply it by 2, but the calculator is doing that for us, and we end up with a total area underneath the curve of 0.0544. And we can go back then to the document. And sorry, did I not share that? Okay. And we've done the test, and we got the p-value, test statistic and the p-value. We compare the p-value to alpha. 0.0544 is bigger than 0.05. Therefore, we'll fail to reject H0. The claim does not include a condition of equality. We failed to reject, so I've got an error here. So this is incorrect. It failed to reject, but I think our conclusion is correct. There is not sufficient sample evidence to warrant rejection of the claim that mu1 equals mu2. And we're using the warrant rejection because we had a claim that included equality. Okay, so let's go then to the last two problems are partial hypothesis tests, similar to all the other sets of problems that we've done for the other hypothesis tests. First one is where we are given a test statistic and critical value, and the test has been done all the way down through step 3. We just need to state the, make a decision and state the conclusion. So we do have to make the decision. So we do have to compare the critical value and its location with the test statistic value. So if we draw the line, and I strongly suggest that you draw a picture for all tests of using the critical value approach. So we draw a picture, and the horizontal axis are values of t, the mean is 0. We plot the we plot the critical value, which in this case is negative 1.725, which was given to us. And we plot the test statistic to see if it falls underneath, or is it farther from the mean than the critical value, in which case it would be in the rejection or critical region. And it is not. It is closer to 0. It is negative 0.65. Therefore, it is not considered to be unlikely. And therefore, it is, we're not going to reject H0. We're going to fail to reject. Okay, and then we state our conclusion. The claim did not include equality, and H0 was not rejected. Therefore, there's not sufficient sample evidence to support the claim that mu1 is less than mu2. Okay, so let's look at the last problem. And this one, we have a significance level of alpha, and the claim is that there's no difference between growth times for plants from two types of seeds, which means no difference means equal, so that means mu1 equals mu2 is the claim. It's a two-tailed test, obviously, but we are given the information from step 2, which is that we have the test statistics 1.997, and the p-value is found to be 0.0520. But we don't care about the test statistic in this case because we have a p-value. All we have to do is finish the test with a decision and statement of conclusion. And our decision is based on p-value, so we just compare the p-value to alpha. 0.0520 is bigger than 0.05. So since it's greater, we're going to fail to reject H0. And the claim includes equality this time. So we're in the flow chart, we're going straight across and we fail to reject. So we're going straight across and then down to the second statement. And that is that there is not sufficient sample evidence to warrant rejection of the claim that mu1 is equal to mu2. And that pretty much wraps up all the problems we have right here for test of difference between means.